here we're going to try to write the equation of a rational function if we have its graph. And so this is really pulling together all the stuff about how do I find vertical and horizontal asymptotes, and now we're turning them kind of backwards. So first, what kind of stuff do I notice on the graph? Well, at x equals 1 and x equals -5, I have vertical asymptotes. So think vertical asymptotes happen where the denominator equals 0, right? Stuff that's not in the domain. So if I'm trying to come up with what does some function look like, for 1 to not be in the domain, this must somehow be in the denominator, and for -5 to somehow not be in the domain, this factor must somehow be in the denominator. So the vertical asymptotes will tell you something about your denominator. Now notice these points here, my x-intercepts, so places where my output is 0. Well, to get the whole function equal to 0, right, for a fraction, you need the top equal to 0. So they're telling you it looks like the top equals 0 here at 5 and here at -4. So for the numerator to equal 0 at those places, there must be an x minus 5 on the top and an x plus 4. That way if I put in something like 5, it is 0 divided by something, so I get 0. So I get that point out of it. So picture at that point, the only thing you don't know is, hey, maybe there's a coefficient out front of this. So I have essentially my whole function based on just the horizontal and vertical asymptotes. All right, so what's a good way to figure it out? Well, a lot of times they tell you a point, and you can plug in that point and try to solve. Now, if you want to be really tricky, like in this one sometimes, see how we have this horizontal asymptote at y equals 2? And so if you remember, horizontal asymptotes only happen if the top degree is bigger than the bottom, you don't have any. If they're the same degree, you take the ratio of the leading coefficient here over the leading coefficient here, and if the bottom has a bigger degree, it's at y equals 0. So the only way you could get one at y equals 2 is if the top and bottom were the same degree. Well, currently notice we have them as the same degree. This one would be x squared and this one would be x squared also. And so we can tell, oh, if y equals 2 is a horizontal asymptote, it must have been that the leading coefficient of the top was maybe 2 and the bottom one was 1. But then we'll use this other point they tell us on the graph to check and see if that actually works. So there was another point they labeled here, -3, 2. So I know when I make x -3, my output is 2. So let's put that into our equation. So my output is 2 when I make all the x's -3. So -3 minus 5 is -8. -3 plus 4 is 1. -3 minus 1, right, I'm putting in x is -3, is -4. And -3 plus 5 is 2. So this looks like 2 equals a times, the negatives will cancel, 8 over 8, so 1. So it looks like a is 2. See how that went along with what we thought here? So now we know our whole equation.